2 nya stjärnskott kanske vi får hit då nästa vecka igen. Får jag nu säga hjärtligt välkommen till Marie Gimber. Från Uppsala. Marie som vann Talang 85 förra året.
Ja,
en riksomfattande tävling som har sin final nere på Kinateatern i Stockholm. Hur kändes det?
Fint, det var ju så jag träffade dig.
Ja. Tack för den passningen. Marie, det här med sång, det är inte någonting som du direkt sysslar med dagligen precis. I varje fall inte i ditt ordinarie arbete.
Nej, inte riktigt.
Tala om vad du gör.
Jag är jurist, jag jobbar som tingsnotarie. Alltså jag gör min tingsmeritering på tingsrätten i Jakobsberg.
Tingsnotarie?
Jaha.
Vad gör en sån?
Vi kan ta ett exempel. Vi säger att Bosse Larsson är ute och kör i Järfälla kommun. Ja. Och han kör för fort, säger poliserna. Men jag kan tänka mig att han är ganska envis till Bosse Larsson, så han säger att det är fel på radarkontrollen. Ja. Jag har inte kört för fort, det är inte min bil och jag var inte ens där och sådär. Och då kommer målet upp till tingsrätten och då sitter jag där och då ska du veta att du inte har en chans.
Tur att du inte sa det där innan programmet, för då hade aldrig fått vara med. Jo, jag ska.
Å andra sidan så får jag också döma i mål om förargelseväckande beteende. Och det kanske är mer aktuellt.
Varför tittar du på mig för?
Jag tänkte det kanske är mer aktuellt om man nu ska ta dig som exempel. Men det är mest trafikmål som jag dömer i. Ja.
Det var bra. Tack för det. Jaha. Men nu ska du i alla fall sjunga för oss. Hur blir det nu? Ska du bli tingsnotarie i fortsättningen eller ska du fortsätta med sången?
Nej, tingsnotarie är man bara i 2,5 år och jag slutar i april.
Vilken tur.
Ja.
Hur länge? I april sa du det?
Ja, just det.
Ja, då kommer jag i maj. På bilen till Järfälla. Vad ska du sjunga för?
Jag ska sjunga en sång som från början heter You Don't Have To Say You Love Me. Sen sjöng Marianne Kock den på Svensktoppen 68, Vackra sagor är så korta. Sen är det en textförfattare i Uppsala som heter Olle Näslund som har skrivit om texten till Vackra karar är så korta.
Fest i förrgår natt såg en vacker karl som satt. Men när jag gick fram och log så såg jag att han stod. Jag är inte någon gigant, ändå att varenda karl jag tror syns knappast när han står. Vackra karlar är så korta, varför är det så? Bo var 1,28, Sven 1,22 och Roger och Bertil var dryga 1,40 och Rune var 1,35. Det sägs visst att storleken den är oväsentlig den. Jo men sant. Men visst vore det väl topp om killen kan vackra karlar är så korta, varför är det så?
2 nya stjärnskott kanske vi får hit då nästa vecka igen. Får jag nu säga hjärtligt välkommen till Marie Gimber. Från Uppsala. Marie som vann Talang 85 förra året.
Ja,
en
stämmer.
riksomfattande tävling som har sin final nere på Kinateatern i Stockholm. Hur kändes det?
Fint, det var ju så jag träffade dig.
Ja, tack för den passningen. Marie, det här med sång, det är inte någonting som du direkt sysslar med dagligen precis. I varje fall inte i ditt ordinarie arbete.
Nej, inte riktigt.
Tala om vad du gör.
Jag är jurist, jag jobbar som tingsnotarie, alltså jag gör min tingsmeritering på tingsrätten i Jakobsberg.
Tingsnotarie?
Jaha.
Vad gör en sån?
Vi kan ta ett exempel, vi säger att Bosse Larsson är ute och kör i Järfälla kommun. Ja. Och han kör för fort, säger poliserna.
Jaha,
men jag kan tänka mig att han är ganska envis till Bosse Larsson, så han säger att det är fel på radarkontrollen. Ja. Jag har inte kört för fort, det är inte min bil och jag var inte ens där och sådär. Och då kommer målet upp till tingsrätten och då sitter jag där och då ska du veta att du inte har en chans.
Det var en ryslig tur att du inte sa det där innan programmet, för du hade aldrig fått vara med. Jo, jag ska.
Å andra sidan så får jag också döma i mål om förargelseväckande beteende. Och det kanske är mer aktuellt.
Tittar du på mig för?
Jag tänkte det kanske är mer aktuellt om man nu ska ta dig som exempel. Men det är mest trafikmål som jag dömer i. Ja.
Det var bra. Tack för det. Jaha. Men nu ska du i alla fall sjunga för oss. Hur blir det nu? Ska du bli tingsnotarie i fortsättningen eller ska du fortsätta med sången?
Nej, tingsnotarie är man bara i 2,5 år och jag slutar i april.
Vilken tur.
Ja.
Hur länge? I april sa du det?
Ja, just det.
Då kommer jag i maj. På bilen till Järfälla. Vad ska du sjunga för?
Jag ska sjunga en sång som från början heter You don't have to say you love me. Sen sjöng Marianne Kock den på Svensktoppen 68, Vackra sagor är så korta. Sen är det en textförfattare i Uppsala som heter Olle Näslund som har skrivit om texten till Vackra karlar är så korta.
På fest i förrgår natt såg en vacker karl som satt. Men när jag gick fram och
great deal because of the newly achieved mobility. We hope that many more profoundly mentally handicapped people will get the same opportunity, and we hope that our experiment has shown a way for further developments.
The automobile is a century old and still as young as ever. But at the moment it's faced with constraints and criticism. Traffic jams, pollution, the energy crisis, accidents, stress, and its effect on the environment. Uncontrolled growth or the price of success. One thing is certain at the dawn of its second century: if the automobile is really going to fulfill its role as the vehicle of individual travel, a symbol of freedom, it's going to mean ensuring unprecedented safety and organizing traffic flow for maximum efficiency and convenience. The European vehicle manufacturers have decided to take up the challenge by setting up the Prometheus research program. Prometheus, a program for European traffic with the highest efficiency and unprecedented safety. ProCar, the basic concept of Prometheus, is active safety for vehicles. ProCar makes use of the most advanced microelectronics. As well as controlling the engine, the electronic systems will cooperate with the driver to help him control the vehicle. The onboard computer makes use of a whole network of sensors to permanently monitor the vehicle's sensitive subsystems. Using a graphic display or synthesized voice, the computer warns the driver of any malfunction and will provide on request a complete diagnosis of the condition of the vehicle. It tailors the service program according to actual use. Highly developed artificial intelligence programs at present being tested on simulators will be used so that the onboard computer will be able to give effective assistance to the driver wherever safety is concerned. This means further development and standardization of systems which are already advanced, like anti-lock braking to allow safe braking in critical situations. It means using electronics to control four-wheel drive to attain astonishingly good road holding on slippery surfaces. And on top of that, the development of automatic trim systems to attain faultless directional stability. New multi-sense sensors will allow the computer to monitor and warn the driver of dangers hidden by obstacles, by darkness or by fog. Depending on the urgency of the danger detected, the expert system, acting like a co-driver, will decide either to alert the driver or to take the action analyzed as being the most efficient to avoid a collision. With the ProNet concept, the active vehicle safety systems of the ProCar concept are completed by inter-vehicle safety devices. Each car emits a radar signal which is picked up by the computers of other cars. The computers then continuously monitor their respective positions and courses and inform each driver as to safety distances calculated for speed and external conditions. When danger is detected, the expert systems in each vehicle will instantly assist the driver and intercommunicate to decide on coordinated action to avoid collision. By means of this permanent real-time interchange of data, the expert systems can automatically regulate the optimum distance between vehicles. For example, on fast roads, aerodynamic suction forces will be used to reduce fuel consumption, giving smoother traffic flow and increased safety. A further line of research, the pro-road concept. Communication between roadside and on-board computers. Good traffic flow also depends on good traffic information. Warning signs of various types at the roadside are already in use. This information will be doubly effective if completed by on-board data. Computer memory systems like the compact disc can store the maps of all the countries in Europe and plans of the towns on a single disc. With the aid of new types of sensors, or using satellite positioning, the onboard computer will be able to follow the exact position of the vehicle on the maps in the memory. The computer will become a real co-driver, guiding each vehicle as traffic information is received. The computer receives radio messages from a server center which permanently collects information relative to the area being driven through. For example, hotels and parking lots that are full, service stations open that night, condition of roads, traffic jams, temporary roadworks or diversions on the route being taken. In addition, the position data and probable itinerary of each vehicle are collected locally by a central traffic control system supplying the onboard computers with optimized routes. So the pro-road concept will be very important in making tomorrow's motoring safe and convenient. The Prometheus program is backed up by 4 research projects coordinated by the most advanced European institutes. The Pro-Chip project to develop necessary electronic components of the right size and reliability for integration into vehicles. Pro-Art to develop the principles required for using systems of artificial intelligence. Pro-Com to optimize communication between vehicles, road and environment, and to harmonize interfaces. And finally, ProGen, to develop appropriate traffic engineering by working out scenarios of the traffic of the future. This highly original research effort, the Prometheus program, is being undertaken jointly by a number of leading motor manufacturers as part of the Eureka program. It will pave the way for European industry to build the automobile of the 21st century.
Throughout the world, Denmark is recognized for her cultural heritage, and we still listen to the voices of yesterday. But Denmark is fast achieving global recognition. recognition for its highly skilled technology. Building on the newest ideas in industrial design and know-how, we have acquired the ability to solve the most challenging problems of tomorrow.
Per Olsen. Goddag. Ja, der er det.
Since 1965, the Per Olsen Company has been solving design and manufacturing problems. The company is universally recognized today for capability, flexibility, and reliability. Per Olsen has risen from a conventional line of production into a brand new world of highly specialized aerospace technology. Over the years, the firm has acquired a wealth of experience in this field. Today, we're able to come up with the right solution to virtually any task proposed by commercial or defense enterprises. Olsen masters a wide range of highly advanced manufacturing techniques in the development of aerospace systems. Our capability spans the entire gamut of production, from initial design to finished product. The F-16, Fighting Falcon, backbone of air forces throughout the Western world. Vertical stabilizers and pylons are vital components of these aircraft. Per Olsen manufactures them. Vertical stabilizers and external fuel tanks for the Swedish Saab Draken fighter. Canards for the Vegan, also made in Sweden, as well as tail cone and thrust reverser housing. The winglet for Gulfstream Aerospace Corporation's business jet 3 and 4. Sponsons for Westland Lynx helicopters and various CNC machine frames and other fracture-critical parts. Wherever there is a demand, the Per Olsen Company has the answer. Only qualified personnel mastering project management, quality assurance, and configuration control have the necessary skills to handle projects involving advanced materials and technologies. Reputations are staked on quality. Per Olsen's quality control system meets AQAP 1 standards, corresponding to MIL Standard 9858. Capability, flexibility, and reliability are common denominators for the accurate and delicate production of the winglet for the Gulfstream business jet. A winglet is a study in precision manufacture. More than 95% of the aluminum block is machined off in making the skins. Advanced machinery matches the honeycomb structure to the skins. Prior to bonding, the structure is surface treated to prepare it for the bonding process. Every step in the process is carefully monitored by engineers in the quality control department. Advanced bonding requires accurate control, so the quality of the bondings is carefully checked by ultrasonic devices. Prior to final assembly, the supporting structure is machined and the fairings are TIG welded. The tools used in the manufacturing processes are also produced by Per Olsen. delicate monitoring at the final checkpoint assures superb standards of accuracy and quality. This is our responsibility because we take pride in our work. Confident of the product's quality and reliability, we ship off another set of winglets to the Gulfstream Corporation. The Per Utzen Company offers a wide range of all-round products, which also cover nautical applications. For example, naval equipment developed with a German contractor and sub-assemblies of missiles co-designed with American contractors. Systems for various space programs have passed through the competent hands of Utzen. The future lies in the skies, and Per Utzen has developed advanced designs and systems for future scientific satellites, a telescopic boom for support of magnetometers and studies of X-ray telescopes. It requires know-how and ingenuity to stand up front in the world of advanced aerospace technology, just as it takes professional courage and high-quality technology to produce medical appliances such as the Per Utzen X-ray scanning table. Carbon fiber reinforced plastics are among several advanced materials required for production, for now and in the future. Throughout production, quality control plays a vital role. Every second of the way, these tools must be monitored for proper function. You see, we're very serious about our business, and we care. Quality control is a vital partner in the assembly of vertical stabilizers and pylons that support the fuel tanks and weapons of the F-16. Per Utzen offers the right solution in matters of development, design, and production of mechanical and electromechanical systems, subsystems, and components. Depending on meticulous Danish craftsmanship and high-quality control for risk-free specific or multi-purpose tasks, the Per Utzen Company commits itself to giving you the future today.
Exploring and developing offshore oil and gas resources represents a challenge to governments, oil companies, and equipment manufacturers. Offshore production accounts for about 27% of total world production. This figure is expected to rise in the near future. Offshore work requires close cooperation between people, techniques, nature itself. High investments and production value demand efficiency and continuous production. High performance and quality of people and equipment working in the offshore environments are the basic requirements. This fits well into the philosophy of Simrad Subsea. Today, our acoustic systems in the field of underwater navigation, telemetry and seabed mapping establish the standards and set the trends for this type of equipment for offshore users. 100 kilometers south of Oslo, in Horten, Norway, in beautiful surroundings by the Oslo Fjord, we find the headquarters of the Simrad Subsea group of companies. Simrad is a well-established performer in the offshore scene in the field of underwater navigation. The Hydroacoustic Positioning System, HPR, from Simrad meets requirements in the areas of dynamic positioning, diving, underwater construction work, survey with ROV and towfish, and drilling. Extensive use is made of Simrad's own 2 vessels during product development and for marketing activities. The vessel Simrad is based in Horten, and Simpson Echo tours European waters for customer demonstrations. In the winter, it is based at the Simrad Technology Center on the island of Madeira. The basic HPR system consists of 1 transducer on the vessel and 1 transponder on the seabed. Acoustic pulses are transmitted from the transducer on the vessel. These pulses activate the seabed transponder, which will give an acoustic reply pulse. For each reply pulse from the transponder, slant range and angular direction to the transponder are computed. These measurements, together with roll and pitch of the vessel, are used for calculating and presenting the XYZ coordinates of the transponder in the vessel coordinate system. Each transponder has different frequencies for reception and transmission. This enables operations using several transponders and minimizes problems normally associated with underwater positioning systems. The presentation on the HPR display in this example shows the vessel in the center of the screen and with the position of the transponder approximately 45 degrees off the starboard bow. The exact alongship, athwartship and depth coordinates are displayed near the transponder symbol and are also available on a serial line to external computers. Drilling is one of the many application areas where HPR systems are used to solve a number of different positioning tasks. In the approach phase, the HPR system will measure the position of the subsea installation relative to the drilling vessel. For the re-entry phase, the relative position of the unit being lowered is measured relative to the target, in this case, the BOP. Note that the display presentation in this case is relative to the seabed transponder marking the target, and that the vessel and drill string are the moving symbols. Simrad has introduced the HPR tracking system with a steerable narrow beam. More than 100 such systems are in operation at present. The tracking system can typically position an ROV, fish or other targets at horizontal distances of 1 to 2,000 meters independently of water depth. The submersible is lowered into the water and the tracking transducer will alternately point the narrow beam towards the transponder on the sub and the transponder on the seabed. On the main control and display unit on the bridge, the position of the sub and the seabed transponder are displayed relative to the vessel, and the symbol indicating the heading of the tracking transducer can be seen at the left. In the submersible control room, the operator follows the operation on a remote video display. Alternatively, the BOP functions can be controlled using a portable unit positioned on deck, on board a standby vessel or in a helicopter. Another application of HPR is the placement of underwater modules. A special version will perform local navigation, ensuring high accuracy also in greater water depths. The local navigation system will then be mounted on the module or tool, which is lowered to the seabed. An area that's in rapid development is remote subsea production systems for oil and gas. This will represent an important technology challenge for instrumentation. At the northeast Frigg, a subsea template is connected to a control tower, which again is controlled by a radio link to the main Frigg center. Simrad has developed and installed an acoustic gas leakage detection system. If a leakage is detected, the system activates an alarm which is transmitted via the radio link to the main Frigg center. Simrad can also deliver systems for acoustic communication with subsea installations and for control and monitoring of other sensors. The EM100 multi-beam echo sounder has a fan-shaped beam made up from 32 beams, each of 2.5 by 3 degrees. In each ping, 32 depth values are captured, covering a depth profile of 1.7 times the water depth. The transducer is retractable and the beam fan is mechanically stabilized in pitch and electronically in roll. The Simrad subsea plant in Horten houses modern production and test facilities. All products are based on high technology knowledge and practical experience. The products are designed and developed in-house. Approximately 20% of turnover is invested in research and development for new products. The main volume of production is carried out by subcontractors, but critical product modules are produced in-house. One example of in-house production are the very complex acoustic transducers. All modules and systems are thoroughly tested and calibrated before being delivered. Today, all products have built-in test functions that are continuously testing all critical functions and parts of the system. High-quality products require testing at all levels. Every product from Simrad has to meet specified environmental limits with respect to temperature, humidity, vibrations and shock in accordance with the classification societies. Advanced computer tools are used during the development and design phase. Computers are also used for thoroughly testing assembled subunits and systems in order to meet the design specifications. From the design stage right through to the final product, Simrad will meet all the requirements of the customer. Simrad has the experience and resources to take on your problem, whatever it may be. A highly qualified staff ensures that Simrad will be a trendsetter in the forefront of new technologies. At Simrad, we're ready to take on the challenge of the future.
proud of the fact that Mobira is without doubt one of the world's leading manufacturers of mobile telephones, and that our international activity is representative of the cream of the industry anywhere. The world market for mobile radio telephones is currently enjoying a period of rapid growth. Finnish-based Mobira, operating internationally and already represented in major markets, are well set for a further improvement in their position as world markets continue to develop. The NMT, Nordic Mobile Telephone Factory at Salo, is producing mobile telephones for such diverse climatic environments as the ice and snow of Scandinavia and the hot, humid tropicality of Malaysia. Mobira intend to keep the lead they've established. Their success is largely due to continuous and intensive research and development. And at the same time as they develop the technology, they produce ideas on how to apply it. Mobira also has a high profile in the rapidly expanding European markets. And in such markets, traditionally dominated by domestic manufacturers, such success is only possible if quality and technology are clearly superior. In Great Britain, Mobira supplies both of the public operating networks, Cellnet and Vodafone. Mobira's strength is not only in mobile telephones. They're strong in the development, production and marketing of public pagers also. The Mobira pager can be reached via an ordinary telephone. Using sub-carrier wavelengths, the paging signal is transmitted over existing FM networks and the contact number can be seen on the pager's display. The majority of the base stations required for the new Nordic NMT 900 system are being supplied by Mobira's Oulu factory, as also are those for the new mobile telephone system in Belgium. In conjunction with parent and associated companies, Nokia and Tele-Nokia, together with Finnish postal, telephone and telegraph authorities at national and local levels, Mobira developed complete public cellular mobile networks for various international markets.
Sitten tässä projektissa valmistautua siihen, että me mahdollisesti joudutaan käyttämään helikopteria noissa tukiasemien asemassa.
Mobira, yet another factory in Espoo, which provides a complete service for special radio telephone system customers, extending from basic design through manufacture and supply, right down to maintenance support for a working system. Designing and testing the software is a time-consuming task requiring absolute assurance. The Espoo factory has supplied many major users in Finland, meeting the communication needs of, for example, the police and airport authorities by designing special networks in close cooperation with the users. The number of base station channels and the specification for the main equipment is individually determined by the particular needs of each customer. Communication between base stations and central equipment is via radio links and telephone lines. In Finland, Mobira equipment is preferred by police, fire, aviation and road transport authorities, as well as by border guards and other government services. In such circumstances, reliability is paramount. In critical situations, the message must get through. There's a final Mobira factory in Äänekoski, which is exclusively devoted to the production of private mobile telephone equipment. The new small systems concept is based on microprocessor-controlled hand portables, vehicle transceivers and base stations. Among other markets, this type of equipment is exported to France and Scotland from Äänekoski. world's top professionals are a visible reference for Mobira. World rally champions use Mobira telephones.
The Finnish Sugar Company Limited is an international company based near Helsinki, specialising in the areas of enzyme biotechnology and animal feeds. Enzymes are natural proteins produced by all living cells, essential for life. They act as catalysts to speed up both the building and breakdown of feed into products usable by the animal. Avizyme is an enzyme cocktail specially developed to improve the value of poultry feed and feed mixtures. It's easy to mix and will boost feed conversion rates and improve live weight gains. Most important enzyme activities found in Avizyme are cellulase and hemicellulase, beta-glucanase and protease. The alluron layer, trapped between the cell wall and endosperm, is a rich source of proteins and essential amino acids, but it has a relatively low digestibility. Thick walls of alluron cells are mainly built up of arabinoxylans, cellulose and polyphenol components which protect the cell contents against enzymatic digestion in the small intestine of poultry. Cellulase and hemicellulase enzymes dissolve alluron cell walls, making utilization of the protein and energy fraction easier. Starch held in the barley or oat grain endosperm is encased in beta-glucans that block its effective absorption. Beta-glucanase breaks down this wall, releasing a valuable starch source and allowing a more effective utilization. Although the cereals used are rich in protein, the quality of this plant nutrient needs to be enhanced to be of maximum benefit. Protease further breaks down the proteins released by cellulase and hemicellulase into peptides and amino acids, and so further improves their digestibility.
The FastCat project, which HTS Scandinavia now presents, embraces a form of knowledge and innovative technology very much like this powerful creation. It is silent, it's powerful, and it's fast. Therefore, it's only appropriate for us to call our undertaking in knowledge and technology FastCat. What does FastCat stand for? FAST stands for high speed, and CAT is computer-aided translation, all combined with computer-aided publishing. Why do we want to take this leap in high-tech applied to linguistic data? The answer is obvious: to provide translators with electronic tools to speed up the translation process while maintaining high-quality translations. How will we realize this? Through a multi-language word processing system and the FastCat Translator workstation, equipped with a high-resolution graphic screen and a very high-speed personal computer that executes up to 22 million instructions per second. This forms an automatic support for translators linked together in national and international networks. The FastCat workstation shows source and target text referring to the language involved. The rapid references and linguistic support are presented to the translator, utilizing multiple high-speed processors which form the user's environment and communication computing power. We are using a network approach. Translators and users of translation services will be able to communicate on standard telephone lines within and across national boundaries. We call the network system FastDoc. The system we offer you includes the following functions: distributed processing, microcomputers, that is, translators' workstations with high-speed personal computers, distributed relational database management systems in multi-language environment, HTS multi-language technology with LC block and velotype keyboard technology, and specialized software products for automatic support for translators. FastDoc, the network system that provides the FastCat, FastComp, and FastMail services online with high-speed communication on standard telephone lines connected by the HTS MIPS-22 network server. MLDBS is the multi-language database system in each country. CapLink is the multi-language publishing system on network, providing FastComp services via the MPS DBS. CatLink provides the FastCat services with automatic support for translators linked in national and international FastDoc networks. UserLink is the user's gateway into the FastDoc network system, with FastCat, FastComp, FastMail services through various types of devices he may already have, such as Minitel, Videotex, PC, terminals, telex, fax. FastMail is a software product on the network that includes an automatic database document exchange system offering several levels of data security. The database holds information about the translator's profile and work schedule and will provide an automatic job control and message link between service users, publishers, and translators. Interlink, the user's support and electronic FastMail link direct on dial-up lines to international databases, translators, customers, subsidiaries, agents, and so on. Now, who is participating in this exciting undertaking? The company in charge of the project is HTS High Technology Solutions Scandinavia AB in Gothenburg, Sweden. The HTS company provides computer hardware, software, and linguistic competence. We produce graphic systems for publication in more than 100 languages: English, Russian, Arabic, Chinese, you name it. The Department of Computational Linguistics at the University of Gothenburg, Språkdata, has been affiliated as project consultant to handle the linguistics side. Over the past years, Språkdata has become well known internationally for its work in the application of computers in the linguistic process, as well as for research in lexicography. From West Germany, the LC Block Computer Technology Company provides a unique computer-controlled keycap Legend keyboard with a liquid crystal display. Key tops can automatically be changed to the character sets used in a specific language. From the Netherlands, one of the contributors is Special Systems Industry BV, with its Velotype, a high-speed keyboard for text entry. The technique used is based on a digital stenographic approach. When will the first outcome of our endeavors appear on the market? Marketing of FastCat products is targeted for the end of 1988. The CAP system for publishing and the FastMail network is available now. It will be gradually expanded during the development of FastCat. Remember, FastCat stands for High-Speed Computer-Aided Translation, a revolutionary tool for translators that is at the same time silent, powerful, and fast. FastCat, computer-aided translation with computer-aided publishing.